folks.
We are not Dimitris. So he's Greek, so at least.
Yeah, at least one of us is half Greek. Yeah,
and
so we're filling in for Dimitris, who unfortunately had to leave yesterday urgently. We'll do our best to fill in for him. We work for him, so we know what we're supposed to say. And hopefully he'll see this and give us a thumbs up.
So we didn't change the subject. So the subject is still how do you craft intelligent application, what I will call AI-infused application with Quarkus. So let's start, because we don't have a lot of time. So what are AI-infused applications? So first, what are LLMs? LLMs are neural networks. So it's complicated things with layered, where you have things that traverse all those layers, and at the end, it predicts something. And what is predict is interesting. It predicts the next token based on the context. So it's like a song that you know, and you heard about it, and you know exactly the next word. That's what an LLM is doing. Except that it's doing that for many things, like text, image, sound, videos, depending on the modality of the model you are using. To do that, these models are trained on a very, very large corpuses of media. You can see all the books, all the image, and so on. They put that in, which means that when you see a recurring pattern, you say, oh, the next one is going to be this. Obviously, it's slightly more complicated, and there is a lot of statistical rules that influence this prediction. And that means that these LLMs are not deterministic. And that's a big change when we deal with an LLM. Generally, when you deal with an API, local API, if it doesn't work, no need to retry, right? It didn't work, you have to fix your code or fix the code that is called. While with LLM, you may retry and you may get a different answer. That's what is cool. So if you retry an infinite number of times, you may get exactly what you want. Maybe a bit expensive, but whatever. LLM can be fine-tuned. I'm not going to discuss this, but basically it's just predicting the next token. So the L from LLM, large language model, means large. So to give you an idea of the size, Llama 3 is 70 billion parameters, was trained on 15,000 billion of tokens. That's a lot of text. You can consider tokens is, it's not really a word, we will see that, but basically it's a word. And on my machine, it's 4.7 gigabytes on disk. Granite, which is an open source model that we're using a lot at Red Hat, it's 34 billion parameters. I think now we have a 70 billion, but it was trained on a smallest corpus of text, and it's 4.8 gigabytes on disk, but also 3.8 gigabytes of RAM. So if you have a really old computer, that's not a problem. So this LLM movement actually is starting giving two trends right now. What I call the very LLM, the very large language model, something you cannot run on a machine or on premise. You need to be one of the big companies to run such kind of things, because it would be so expensive to get that. And then you have the SLM, small language model. Well, by small, I mean 500 megabytes or something like this. So it's not very small. It's decent size.
But something that will be able to run on your phone.
Yes, basically you can run on your phone, local, on-prem. How do you do that? You have plenty of model serving like VLLM, Ollama, JLama in pure Java, Podman, AI Studio, InstructLab, and so on. So, and why it's important, this distinction is depending on the size of your model, depending on the number of parameters, you will have capabilities that are different. So, for example, if you want to just have summarization, 62 billion parameters is enough, even less, a lot less. However, if you want joke explanation, you need 540 billion parameters. Why are jokes so complicated for an AI to understand? I'm not totally sure, but yeah. Anyway, so based on the size, we will have more inherent capabilities. To use a model, well, you need to run a model. And this model is going to run on a model serving infrastructure. When you use OpenAI, you don't see it. When you use Amazon Bedrock, you don't see it, but it's there. And that model serving is actually going to use GPUs to do all the mathematical transformations that are required to do predictions. These model serving expose APIs like REST or gRPC and so on. And then you say, well, it should be easy, right? When you deal with a model, something is slightly different when you deal with a regular API. You first give prompt in plain English or plain Greek or plain French. you actually give instructions using natural language. And models, I like to say that they are a little bit like teenagers. Like, depending which teenagers you talk to, you need to phrase things slightly differently. Otherwise, I won't do the thing. So for models, it's more or less the same thing. You will find a prompt that works very great on one model. You switch to another model, it's terrible. So it's not an API. It's something way more fuzzy than this. And there is some implicit relationship between your prompt and the model. The output of the model, the prediction, depend on the modality of the model. We will see that. It can be text, it can be images, it can be sound, videos, whatever. So what I call AI-infused application or intelligent application. For me, an AI-infused application is a software that has been enhanced with AI capabilities, like summarization, image recognition, whatever. So it's basically an application that interacts with a model. Simple, right? And I said that the model run on a model serving exposes an API. So basically, 50 minutes to discuss, oh, you are going to call a REST call.
40, not 50.
45, well, 40 minutes to just invoke a REST API. That looks like a lot of time. There is a lot of things to understand. It's way more complicated than this. So first, the model will have been tailored by data scientists. So on the top, you have all the data scientist words. They collect data, they do fine-tuning, and at the end, they get a model. On the bottom, that's the developer world. We code, we build, we test, we release, we deploy, we operate, we monitor. And to call these models, we need a set of APIs and abstraction. A REST call is not going to be enough. So we need clients and toolkits that will let us invoke all those models, prompt them, receive the response, implement the different patterns like RAG or function calling, agentic, and so on. So the first problem is that there is not one API. Well, actually, there is a consolidation, so soon there will be one API. If you look at the predictive AI world, it's all about K-serve, NVIDIA, and so on, and basically all the API are tensor in, tensor out. Tensor are large matrices with many dimensions, very unusable by a regular Java developer. It's going to change because that's not really useful. On the LLM one, for chat model, image model, sound model, we have 2 or 3 APIs that are competing, Hugging Face, inference endpoint, which is one, the OpenAI HTTP API, and the Llama HTTP API, which is not retired, but now you can use the OpenAI. Because basically OpenAI, the API is now so used by everyone that everybody is building on top of that. So even if it's not OpenAPI on the other side, you can expose that API, just a REST API. Second thing is that you need abstractions. LLMs are stateless. I'm going to send messages like what I want the LLM to do, and it will reply. And if I just ask a second question, it does not have memory of what I exchanged before. So if I say, hey, hello, my name is Clement, hey, it will reply, hello, Clement. And then I say, what's my name? It will say, I don't know. Great. It's like talking to my grandmother. Anyway, so you need abstraction to actually help you build such kind of things where you have conversations, where you can keep the number of messages and so on. That's what we call context on memory. Obviously, the problem with that is that there is a size issue. You can imagine that at some point, your memory is completely bloated and you don't have any room for anything anymore. So you need to think about eviction strategy, which message you removed, what about when you have concurrent users at the same time? Well, basically, you need abstractions. The second need for abstraction is tokens. As I said, LLMs predict the next token, but tokens are not really word or letter. They are in between. And the fun thing is that each model uses a different tokenizer. So this sentence over there has been tokenized with the OpenAI tokenizer, and the OpenAI tokenizer changed for GPT-4o. So that's for GPT-4o. And you see that there are weird tokens, because typically dot space is a token, but dot is also a token. Not very useful, but they are tokens. And we will see later that when you implement RAG and so on, this tokenization is actually important. Mm-hmm. So another thing about tokens is that context size is determined in terms of tokens. So when someone say, hey, I have a huge context size of X number of tokens, they are not word, they are this. So depending on the tokenizer, it can be big or very small. So you need to know that. Obviously, if you need to keep track of the tokens and so on, it's pretty complicated too. So you need another abstraction that keep track of that and tell you how much token you spend during your conversation. And if you use a model on the cloud, you pay per token. It's not a lot per token, but if you have a lot of token, it can be problematic. So are we doomed? No. Fortunately, we have solution for you. And the first thing is that LangChain from Python is a great toolkit to build such kind of application, but it's in Python and JS. So it has plenty of clients to interact with various models, or you write your prompts, or you build agentic architecture, or you build chains, or you deal with vector store and document loader. So that's for the right part, we will see that. But it's all in Python. And I have nothing against Python. I do Python from sometimes, but yeah, I need something where I'm very comfortable and something where I can actually see how it's going to work in production. Fortunately, last year it was introduced here, there is something called LangChain4j. LangChain4j is basically the same thing as LangChain, but in Java. So you can have you can integrate many models like Gemini, OpenAI models, the Google ones, no, Google's is Gemini, the Azure AI ones, and so on. Or you write your prompt, or you write agents, or you write your chains, or you interact with vector store, document loader, and plenty of other things. So it provides the right abstraction. But it's a toolkit, and that's something to keep in mind. It's really a set of APIs that you are going to use to build and interact with AI. So in terms of abstraction, you will have prompts, message, memory, tokens, images, and so on. So here we see a little bit how it's structured. So we have building blocks, output parser, memory, prompt. So memory is what we keep the messages, the different models, function calling, and so on. You have the RAG part, because it's one of the most common patterns we have, and the AI service. Georgios will show you how it looks like. So now the question is that, okay, cool. We have LangChain4j, we don't need anything. Well, it's using a toolkit, and using a toolkit is at your own risk, because sometimes you need to integrate everything. It's like when you are dealing with a database, won't you use only JDBC, or you use something a little bit more or higher abstraction like Hibernate, and even Hibernate with a connection pool which is managed by your framework and so on. You need this. And basically, when we started playing that, I was like, well, what's the difference? Because Georgios was there last year, so he saw the talk, I just watched the replay, and I was like, at the end, I was like, great, love it. But what's the difference between an application that use a database, a microservice that use another service, and an AI-infused application that use a model? Because basically, it's 3 boxes, 3 different diagrams, and the same red arrows in between. The thing that, when you think about it, all these are actually integration points. And when you build applications designed for productions, these integration points are the thing we actually care a lot, because it's where things can go terribly wrong. Failures, reliability, network issues, serialization issues, and so on, security. And when you think about that, you need a framework and no more a toolkit that will integrate all those features at this level based on the runtime you use. So if you use Quarkus, then it's Quarkus on Chain4j. If you use Spring, then Spring is going to do that, and so on. So observability, fault tolerance, security, connection pooling, and so on and so on. So how it's related to LangChain and LangChain4j. So LangChain4j is inspired by LangChain, okay? And Quarkus LangChain4j, we use and extend LangChain4j. The lead developer on LangChain4j, Dimitro, is working for Red Hat too, so we have regular, even continuous interaction with him. So we have great exchanges. We sometimes incube features in Quarkus to see how it works, and then we contribute them back in LangChain. You will see the add toolbox annotation. Guardrails are on their way to do that. We'll see this later. So basically that's how it works. But LangChain4j is a toolkit, and Quarkus LangChain4j is the integration of that toolkit in a framework. So it provides a lot of things, declarative client, CDI integration, because CDI is a model of development we use in Quarkus, observability, auditing for security, resilience, RAGs, agentic architecture, testability, and one of the key things of Quarkus, a great developer joy. And you will see that we will go back from the codes and DevUI, try a few things, see what really is exchanged with the LLM to understand how things works under the hood, and things like that. So what it means by AI-infused application with Quarkus, it's an AI-infused application, right, but with the right stability pattern, and that is designed for production. And now, I think it will be time for some code.
Excellent, yeah. So our idea here is to like show you what this thing looks like in practice, right? There are a ton of details and a lot more stuff that exists, but in like 40 minutes, we can only do so much. But I do want to bring people's attention to the extended session we did on Tuesday. So myself, Clement, and Eric, we did an extended session of this on Tuesday. So it's already on YouTube. If you want like 3 hours of like immense content on LangChain4j and Quarkus LangChain4j, please check that out. Now, where are we going to start? We're going to start with something, let's say a little fun and very simple to understand as users. What we're going to do is we're going to generate an image, and then we're going to tell basically the LLM what image to generate, and then we're going to ask it what is that image all about, right? So image generator is, again, AI service. So this is what Clement alluded to earlier. The basic abstraction that we believe that you as users will use is this AI service. And what is the AI service? It's basically just an interface you declare. You annotate it with this register AI service and potentially with a few other things. And what it does is that it takes your input, which usually is your prompt. In this case, it will be what the user wants to generate, and it will return something. In this case, an image. So we'll see a lot of other examples. They'll almost all use this AI service concept, which basically you get to define what you need, and we, as the framework and library, will implement that for you. So for folks that are like familiar, let's say, with Spring Data JPA, this is a very similar concept, right? You define what you want, and the framework takes care of all the rest. Now, the other AI service we have is the describer, where it takes the image that we will create, and it will output what it thinks the image is about. So let's try that and see how it works. Now, let's get to the proper to image AI. So in Quarkus, for those who have not used it, we have a special mode where we run the application. It's called the dev mode, which allows a bunch of developer joy things that we will show later. So what I'm doing here now, I'm just running Quarkus Dev. That means that it will go ahead and run this. So in this case, it's just like a CLI application. We don't have any UI or anything. But what I'm doing is that I'm injecting the generator and the describer into like a CLI thing. And I'm going to ask it to generate a picture of a Belgian chocolate going to Devoxx, Belgium, in Antwerp. The chocolate should be wearing a Quarkus t-shirt.
Of course.
Right? Obviously. So let's see what it actually generated. The generation is here. And that's cool, right? It looks like the airport in Brussels, I guess, and it's wearing Quarkus.
It's close enough.
It's close enough, right? So this is like we just in plain text said what we wanted. We described an interface that just took text, return image, and it OpenAI generated like a pretty amazing photo.
And it got Quarkus right, which is
yes.
rare.
Yeah.
That's super rare.
And then what we did is that we passed this image into the describer service, and we said, okay, what does this image describe, right? And the answer from OpenAI was, this image features a cartoonish character that resembles a chocolate bar, prominently branded with Quarkus logo. So it did an amazing job, right? And in this case, the reason I made it into 2 AI services is because we wanted to make sure that there was no chat memory between the 2 interactions, right? So like Clement said earlier, when you want to have the AI remember your conversation, you have to add memory. But in this case, I wanted to show that we don't have memory, that we, on one side, generate the image, on the other side, we describe the image. So these are use cases that like you last year, you could not implement this, right? You needed a whole bunch of weirdo libraries or calling out to Python or whatever. Now this just works out of the box.
And there is two models behind this. Because
yes, that's correct. That's correct. There's two different models. So the image generation model is using OpenAI's DALL-E, and the describing model is using a GPT-4o, right? Which Clement can verify that is better than like any OCR, right?
So what I did, so you see that, okay, but why I can't do, it's not very interesting for my company or for my enterprise. So I did something, I do everything by handwriting. I still write with a fountain pen and so on. The problem is that no one can read myself. Even sometimes myself, I cannot read what I wrote, which is annoying, but anyway. What I did is I'd say, take the picture of that, send it, and it did a very great job at recognizing what I was writing. We have the demo during the deep dive. I recommend you to check that. You can also imagine things like, hey, I want to classify my pictures, like what are the, obviously, because we all do that, what are the picture of cats, what are the picture of dogs, and so on. But you can go way further, like what are the picture where you have a lot of people and so on. You can see how security or things like that can actually use this feature very, very quickly.
Absolutely, absolutely. So that was like the first like very high level demo. We have a few more to go, so let's move on to that.
All right. One of the common pattern, and you are Devoxx, this week is crazy in the sense that everybody has mentioned RAG one way or another. So what it is. So first I'm still relatively skeptical about the RAG pattern, and I will explain you why. So what RAG means, it means retrieve augmented generation. It's a technique to add data to a model, because a model is trained with a fixed corpus of media and nothing else. So if the fixed corpus of media is at day 2023, then everything after 2023 doesn't know it. It doesn't know your private data. It doesn't know the files you have on your file system and so on. So that's a way to extend the knowledge of your LLMs with your own data. So it's actually a two-phase process, ingestion and query. Let's go into details in the ingestion one. So you take documents, whatever they are, PDF, images, text, videos, and so on. The first thing we will do is split them into segments. So the first thing, splitting is not easy. It's not string.split. It's way more complicated because you may want to keep the hierarchy of your document. So if you have clearly unstructured things, that's fine. But if you have something more structured, like a document with titles, headings, and so on, you may want to keep that hierarchy. So it's very hard to tune this. And I'm not going to explain because there is no silver bullet here, but you will have to try it yourself. Once you have the text segment that works for you, you will do one thing, which is, at the beginning I say, well, why are they doing that? So they take those segments, they call another type of model, which is named embedding model, which is basically an LLM without the last layer of prediction, and that returns a vector or a tensor, which is basically a representation, a semantic representation of your model, of your word, or of your text, sorry. We will see why we do that. Then we store this text segment and the associated vector in a vector database. Vector database, there is plenty. There is dedicated one like Chroma and Milvus. You can reuse PG with PG vector, Postgre, sorry, Redis, and so on. So there is plenty of them. Once it's stored, fine. You have a vector store which inside text segment, vector, text segment, vector, and so on. And metadata to, if you want. The second part is where the magic happens. If you ask something like, tell me more about your retirement account, imagine that I am a bank, this is my prompt. So what we are going to send to the LLM to reason about that is not just that query, because it doesn't know about our retirement accounts and the product of my bank. It's going to augment that prompt, so the augmented generation, it comes from here, with the text segment. So it's going to introduce its sentence answer using the following information that you can obviously customize, and the different text segments. Here we have 3 of them from my documents. That's what is depicted here. We get the query, we take that query, and we actually compute the embedding, so the vector representation of that query using the same embedding model that we did for the ingestion part. Now we have that query. the vector, we are going to find similarity between the other segments or relevant segments from the vector store. So we call the vector store and say, hey, give me all the text segments which are close enough, with a close distance from my query. And then it sends this text segment, and we augment the prompt like this. It's super simple when you think about it. It's basically, say, instead of just calling the LLM directly, I'm going to do a search in a database, take those results, attach them, send. You could do that with classic Hibernate or databases, or even full text search. It actually works too, sometimes even better. Demo.
Yeah, so we're going to probably have to do it very simply. So we're going to show like the canonical RAG example, right? So it's basically a chatbot. And this let's go to the proper one. This chatbot, what the interesting thing about it is that we have fed it with a catalog, let's say, of accounts like banking related products, right? I don't know what they are.
Well, I got them generated from AI.
Yeah, okay. Excellent.
Self-inception.
So what we're going to do, again, we're going to launch Quarkus DevMode. And let's see what we get here, right? This one does have a UI written by Clement. He's like an expert JavaScript developer. So let's see once it loads.
This is absolutely wrong, huh? Right?
Let's see. Okay, here it is, chatbot. It's called Bank Buddy. And let's see what it can do. It says, hello, I'm Bob. How can I help you? And I'm going to say, what can you do for me, Bob?
So his laptop has a... Remember, but you can actually write whatever you want. Huh? It's not, it's not a fixed size.
I'm too lazy, yeah. So Bob answers with a bunch of information that it has not been trained on, right? It doesn't, the model itself, like OpenAI, doesn't know what this elite money market account is, right? But because we augmented the prompt, it answers with this. And if I follow up and say, tell me more about elite money market account. Let's see what happens.
So every time you get a response, it actually computes the vector of the query, search in the vector database, get the relevant information, send that to the LLM, augment the prompt, send that to the LLM, and print the result.
And this stuff is basically like what was in the TXT files, right, that we had earlier. But let's see about a little in the DevUI, what this looks like, right? So in Quarkus, we have this, again, as we said, DevUI. I can go here and press D, but it's essentially goes to Q/DevUI. And if I go to LangChain4j chat, right, this is where you can like write any chat you want. But the cool thing here is we're going to see what is actually sent over the wire. Tell me about elite money market account. And now, this is me, like what I sent. This is the system message. So this is the one we created with the AI service and told it what the context is. And
Nope.
Oh, sorry.
No, that's me, I believe.
Yeah, okay.
I click on the pointer. It's a Linux system.
Well, at least this time I can type, because on Tuesday, if you watch the demo, you see that like I was using Clement's Mac, I absolutely could not use it. So this is a little better. So the interesting part here is that I actually wrote, tell me about elite money market account, but this is what we sent to OpenAI. And this is where the magic, where Clement mentioned earlier. The framework adds this, like answer using the following information, and then it pulls the information from the whole RAG process and sends this to OpenAI, right? And then OpenAI returns this. And this is the awesome thing with this DevUI, right? You can get to see behind the scenes what is actually going on, and this is super useful for like understanding. And
we will see that later with the tools.
Yeah, if we have enough time. Yeah. So let's we have another RAG one, right? Yeah. Okay. So yeah. Go.
No, we don't. So there is some limits to the RAG pattern, as I said. So the first one is how you split the document. It's super hard. You need to know how, well, if you want to keep the hierarchy, what metadata you add, and so on. And sometimes it just doesn't really work, so you really need to tune this part, and it can be very time-consuming. Then you have two problems with RAG is overmatching and undermatching. The overmatching is you ask a question, like, what about retirement plan? And it's doing a vector of that, okay, fine. And for a strange reason that we don't work like this. It believes that the best token or the most relevant token in this is the space you have in between. There. So instead of finding anything about bank accounts and things like that, it will say, oh, I'm going to retrieve all the text segments which also have a space or something like this. So you can immediately see that sometimes you get way too many documents that are actually not very relevant. So there are solutions for that, but if you don't do it right, you may have a large number of documents. You are going to limit the number of text segments you extend your prompt with, and then you get incomplete and inaccurate answer. Another thing is that for OpenAI, for GPT's models, they are really good, or Claude are really good, so no problem. But if you use more SML and you send too much data, they start freaking out. And they can't really find the right semantic between all the noise you send. So you need to be careful of that. The undermatching is also a problem in the sense that there is a query, but it didn't find anything relevant. So, and in that case, well, we didn't find any relevant data, fine, but we still ask a question to the LLM. And again, LLM are like teenagers. And when you ask a teenager a question, they don't have the answer, they made up an answer. Well,
did you do your homework?
Yeah, typically, that's the kind of, and I will say, yeah, sure, I did everything. So in that case, that's what we call an hallucination. The model just like making a complete fake answer, and obviously you don't want that. Advanced RAG is when you take the second part of the RAG, but you start doing things a little bit more carefully with a lot more hooks and phases and so on. And that one approach, there is also a graph approach and chain approach. There is multiple ways of doing that, but basically we are starting decomposing all these in different phases. So typically the query transformer can take all the context instead of just the query. The query router, you can decide which content retriever you are going to use. Content retriever are things that will interact with embedding database or regular database or a web search and so on. Then you have the aggregator and the injector. All these components are simple CDI bin in Quarkus. You can implement them as you want. And because they are all CDI bins, they can also use other dedicated AI services to do their job. Like the query transformer could be take the whole context, all the messages sent, build a summary, and build a vector representation of that. That will avoid the space issue. The query router can say, okay, I got that question. What will be the best retriever? So you can ask an LLM to do that, or you can code it. And in terms of content retriever, everybody is speaking about embedding, but you can also imagine that inside your regular Postgre or MySQL database for all varchar, you also compute the embedding, and so you could search there. Or you can use Hibernate search and do full text search. So there is actually no real dependency on embedding model. Mm-hmm. We have a sample in LangChain4j where we actually we have a regular database, and we ask the LLM to generate the SQL statement to get the most relevant rows from that database.
Yeah, we have that. But yeah, we have links to it later. I don't think we have time for it now. So essentially what it does, it creates SQL queries based on the questions you ask it, and then it executes it against the database. Really cool stuff.
Yeah, and actually way more efficient and accurate than the regular embedding and similarity search. Why? Because my data was structured data. So the second pattern is function calling and agentic architecture. Well, let's go one step further. Let's allow the model to invoke code from your application. What can go wrong, right? So typically, let's give access to the database or whatever. So to do that, we have a regular question, okay? And we're going to augment the query with what we call tools descriptions. Tools description are functions that we have declared in our code that we say, hey, model, you are allowed to use that tool, and that tool. We will see how it's implemented. We send all this to the model, and the model will reason about, and if you realize that it needs to call one of these functions, typically because there is something it doesn't know, or it needs to do something like canceling a booking, querying your database, or something like that, it will return a response with invoke that tools with these parameters. So the model tells you exactly what needs to be invoked. You as framework, you do that, you send the result back, and then the model will continue to reason, because maybe it will call a second tools, and so on and so on. And at the end, it will return the complete response. So how does that work? Well, very simple. We have our AI service. That doesn't change. You add toolbox, and you list the classes, which are actually beans, where you have declared add tool. And inside your classes, you have the add tool annotation containing a description, and that's what we send to the model. So the model receives your question, and also these tools that say, hey, you can call that function, and that function calculates the length of a string, and things like that. If you omit the description, it will use a function name as to detect what it is doing, so be careful to use meaningful names. Another example before the demo is you can do that and give access to your database. And that's actually what we are going to show us.
Yeah, we can do that.
What can go wrong here, right?
Nothing. So in this case, we have this example is like RAG and tools. So let's go and see at CD, and not image model. And it's at Quarkus AI Services, guardrails, function. Should be at 5 function calling. And we have what here? We have, no. We want the whole thing. Okay, yeah. So we have the examples, which
is in 0.
Yeah, it's at 0. Yeah. So obviously we're developers, so it starts from 0. Examples. And I think it's 2 chatbot. Yes. Launching dev mode again. And then this one, let's look at it a little bit, right? So we have, like, there's a bunch of RAG-related stuff, but the support agent says that the AI service that we actually care about says that you're a customer support agent for this company called Miles and Carl, the company called Miles and Smiles, and you answer questions, right? And you have access to some tools, and these tools, in this case, can cancel a booking, or they can like list all your bookings and stuff like that. And obviously, since it's RAG, it also has a bunch of information about the cancellation policies and whatnot. So let's go and actually run this. UI should be very similar.
Yeah, because I implemented once and reuse everywhere.
Obviously. Okay, how can I help you? I want to cancel my booking. Let's see how this will work. So we're asking a question, no context, I want to cancel my booking. And it says, to assist you, I'll first need to check the details of your booking. Okay, can you give me first name, last name, booking ID? And let's see what we added this stuff to a database, and we're going to say my name, okay, I'm Speedy McWheels. Very real.
These names
very real.
Yeah,
so
also AI generated.
Thank you, Speedy McWheels. Can you provide your booking ID? I don't know it. Which bookings do I currently have? Let's see. How smart is it going to be this time? You have 3 bookings. Okay, I want to cancel the first one. Let's see.
And every time we do that, it is going to send this with the tools come back with a tools request, say, okay, you need to list all the booking from the database, we send that back, and reason about, and send this.
The magic here is that all we did from a, let's say, intelligence perspective is that we said, you are a customer support agent, and we gave it access to the tools, right? Which were the cancel, list, blah, blah, blah. And in this case, I couldn't cancel because it also knew that like the cancellation policy is that you can't cancel like 3 days before the booking or whatever. But the awesome thing here is that these tools, you write them in your normal approach that you would with Quarkus with everything else, so like CDI and all the annotation-based cool stuff, and the framework itself knows when to call this stuff and how to convert like results from one thing to another.
So let's try something.
Yeah.
In your
and I think we're gonna have to
your instruction and delete.
Now we're gonna try to do a prompt
booking.
injection. See how that works. Awesome.
Here we go.
And show why it doesn't work.
So why it doesn't work? It's because in Quarkus LangChain4j, we also have, guardrails. And guardrails are functions that you can call before calling your LLM or after calling your LLM. And typically here, I have implemented one which detects injection, so prompt injection, so like SQL injection, but for AI. And how do I implemented it?
And here's the cool part.
Yeah, because, well, I could do very complex things and finding if there is a keyword, something like that, or I could simply have another AI service. Not this one here.
So it's just another AI service, right?
Yes, which is different instruction, obviously, which in that case is dedicated to do that. It's trained with it's prompted with a technique that we call few shots. So we give some ideas about what needs to be done. And then at the end, it computes a score. And that score will determine if there is a prompt injection or not. So your guardrails can actually use other AI service. Like your content router could use AI service and so on and so on. There is other way to detect prompt injection. That was just one other way.
Yeah, so the idea here was to show you how all of this stuff like blends in with the normal Quarkus developer experience, right? So you just program like an enterprise Java developer like we all love, and everything will just work as you expect. So yeah, let's probably...
Yeah. So guardrails, that's exactly what okay.
Yeah,
so let's conclude. One thing that we didn't show you, for lack of time, it's observability. Basically, it just works. So there is almost nothing to show you. You have the right dependency. You have all the tracing metrics, all reported to your Kibana, Grafana,
Jaeger,
Prometheus, Jaeger,
everything
and
just
so on.
works without you doing anything.
Yes. Let's conclude. So that was a very short talk about Quarkus LangChain4j. It is doing a lot more than this. You can get the slide over there. You can get our documentation, which is far from being perfect, at that link here. We hope you enjoy it and you enjoyed your lunch. And Quarkus Core reached 1,000 contributors 2 weeks ago. We are very happy of that milestone. Thank you. If you're one of these, thank you very much. And we hope you get your pictures next year on this. 2 more talk about Quarkus today. Introduction to Quarkus security. If you are in the security land, very important. And the last one from Holly, which will explain why Quarkus is going to save the planet. With a teasing like this, you can't miss it. All right, thank you.
Thank you.